Hello everyone, this is Pallavi Pujar from Biotecnika. I hope you are already enjoying our NEET live sessions every day and already you have marked in the calendar also, right? Already you have completed your 3 biology sessions and 1 chemistry session, and this is our 5th day of Nail the NEET Revision Series. I hope you are enjoying it very well, right? So if you are present, students, so just ping me in the chat box. I hope I can start it once you ping. Yeah, hello. So just let me wait for 1 to 2 minutes. Then we can start with our organic chapter, which we already, maybe you have studied about this, but just I am going to revise it. Okay, just nail it together. So students, please join faster so that I can start it easily. Yes, okay. I guess you will join me soon and I will be waiting for you all. And I want to tell you one more thing, that after completing this session, there will be available of feedback form in the description box. Just fill that feedback form and you will be getting the free notes of NEET, that is important topics of NEET series. Okay, so what and all you have to study, important topics of complete NEET syllabus of chemistry part. So just go for it and please stay tuned with me last minute, till last minute. Okay, so just let us start with the aldehyde, ketones and carboxylic acid chapter. I hope it will be very easy for you, but even though I know, I want to make you feel more easier. Okay, so before entering the actual part, that is preparation and chemical reactivity of aldehydes, ketones and carboxylic acid, now you have to know what and all the concepts are important from this chapter. Okay, so there are so many subtopics in this. Okay, so firstly the nomenclature and the structure, I hope you know how to name the compound, right? So that part is important. And apart from that, preparation and chemical reactivity, I am going to teach you completely. Let's revise it. And now nextly, it is physical properties of aldehydes, ketones and carboxylic acid. Just some physical and chemical properties you have to study, so even that is important. And apart from that, uses. Okay, so these all are the important subtopics of aldehydes, ketones and carboxylic acid chapter, right? So now what we'll do, we'll start with the actual part of aldehydes, ketones and carboxylic acid chapter. So coming to first thing, I want to tell you that what exactly the carbonyl group, right? So we have so many functional groups in organic chemistry. We have so many, like simply we start with amides and esters, carboxylic acids, aldehyde. What exactly we can differentiate each and every functional group? We can differentiate them based on the presence of functional group, the presence of the carbonyl group, right? So there you can see presence of carbonyl group. Okay, so this is what the carbonyl group you can see overall. So only the thing, the differentiation of the functional group can be seen here overall. Just I will share you. One is aldehyde, where you will be having one alkyl group, and apart from that, ketonyl group, where you will be having two alkyl groups. Apart from that, any other functional group where the carbonyl group is present, that is ketone, which is connected to one side hydroxyl group and other side R dash, any alkyl or aryl group you can say. Apart from this, you can have ester also, right? That is RCOO, R dash, and amide also, where you can write it RCONH2, right? And acyl chloride also you can have, where you can see the carbonyl group is present in the compound, right? So there are so many carbonyl containing functional group in organic chemistry, right? Right now we have to concentrate on aldehydes, ketones and carboxylic acid, whether their reactivity part is changing or how exactly we can study them, right? So just start with this. Before that, Just let me show you few things regarding aldehydes and ketones. Okay, I hope the students are already they're enjoying, and Reshma is joined just now. Yes, hello Reshma. Okay, so like that, students, please join me faster. Just crack it. Let us crack it. Okay. Okay. So coming to the aldehydes, ketones, you can see here, this is the carbonyl group. So the first thing where in case of RCHO, if I write, so this R can be alkyl also and aryl also, right? Alkyl also, aryl also. In the first example, you can see it is formaldehyde. So R, what it is? So R is here, it is just simple hydrogen, formaldehyde, right? Now, if we replace this R by CH3 group, okay, if we replace the R by CH3 group, then it will be acetaldehyde. So just we can simply write like CO, okay, H and CH3. So this is what aldehyde. Coming to ketonyl group, as already I have told, two carbon atoms are attached to carbonyl group. Okay, what is the difference between aldehyde and ketone? The carbonyl group, if it is attached to one side hydrogen, another side methyl group or any aryl group, then we can say it is aldehyde. If it is attached with two different carbon atoms or the similar carbon atoms or alkyl or aryl, if you mention, then it is ketone. Okay, and with respect to carboxylic acid, so this same carbonyl group will be attached to OH, and another side it may be alkyl or aryl group. Okay, so this is what we can say with respect to the carbonyl group containing functional group, right? All right, already you have understood, I guess. Now just let's start with the preparation reactivity part of aldehyde, ketones and carboxylic acids. Okay, so just before starting the preparation of aldehyde and ketone, just let me know any other student has joined. Yes, you all are joining, I hope. Okay, so coming to the preparation part here, so the preparation of aldehyde and ketone, we can either study it separately, like aldehyde preparation separately and ketones preparation separately. Apart from that, carboxylic acid preparation separately. So aldehyde and ketones, where the reactivity part and the preparation, where we can start from the single reactant like oxidation or the dehydrogenation, where the three way we can categorize them and we can study them. Okay, so first we'll start with the oxidation reaction. So the oxidation of primary alcohol, always it will give me aldehyde. Okay, oxidation of primary alcohol, always it will give me aldehyde in the presence of PCC and PDC. So always the primary alcohol will give you aldehyde and the secondary alcohol will give you ketone. So this you have to remember. So just I am marking here. Please mark it. Okay, so primary alcohol will always give you aldehyde upon oxidation in the presence of PCC or PDC. So here the PCC is nothing but pyridinium chlorochromate and PDC is pyridinium dichromate. Okay, so here this mild or weak oxidants, we can say the mild oxidizing agents, if we use, we can get aldehyde. Suppose you use any strong oxidizing agents, then definitely the alcohol will be converted directly into carboxylic acid. Okay, that's why if we want aldehyde, we have to use mild oxidizing agents or oxidants here. Okay, so right now I'm using PCC and PDC in both the oxidation reactions of conversion of alcohol to aldehyde and nextly secondary alcohol to ketone. Okay, so this is what oxidation. So we are done with the oxidation now. So next reaction is dehydrogenation of alcohols. So what exactly dehydrogenation of alcohols? You know, the same alcohol you are taking, primary alcohol, in the presence of copper catalyst, and you are maintaining 573 Kelvin, and you will get acetaldehyde here. So whatever you are getting aldehydes from alcohol, so just two different case of reactions. One is oxidation, another one is dehydrogenation, and the reagent you are changing. In oxidation, you are using oxidizing agents. In dehydrogenation, you are using copper and you are maintaining temperature. That's it. Nothing else is there here. Okay. Now coming to secondly, the secondary alcohol will give you ketone upon treatment with copper under maintaining 573 Kelvin temperature, right? So the same thing, the secondary alcohol will give you ketone, primary alcohol will always give you aldehyde. So you have to note it. Sometimes in order to confuse you in the question, they may give you differently. Okay, so you have to know. And the last reaction is what happens if we consider tertiary alcohol. So the tertiary alcohol, whenever you consider in the presence of copper and 573 Kelvin temperature you are maintaining, you will get simply hydrocarbon. That is alkenes you will get upon treatment with copper and by maintaining 573 Kelvin temperature. So this is what dehydrogenation of alcohols. So we have completed oxidation, dehydrogenation of alcohols. Now we'll further move on. Any other method can we prepare aldehyde? Yes, we can prepare. So from where we can prepare? We can prepare from hydrocarbon also. So from hydrocarbons, as you can see here, this is alkene, right? Substituted alkene you have just upon ozonolysis, you are going to get the mixture of aldehyde and ketone. So this ozonolysis, whatever you are getting the products, it will be mainly depending upon the alkene which you are using. Suppose you're simply using the alkene, simple CH2 double bond CH2, you may get just aldehyde. Suppose you are using the substituted alkenes and you will get aldehyde along with the ketones. Okay, so what type of reaction condition and the reactant you are using, based on that you will get the corresponding aldehyde and ketone. Okay, so this is what ozonolysis reaction. Now next reaction is hydration. Okay, so just hydration of alkynes in the presence of mercury sulfate and acidic media, that is H2SO4 also you can use here. So by using, you are getting aldehyde. Along with that, whenever you are taking substituted alkyne in the sense, you can see in the first reaction here H and C triple bond C, H is there, and in the reactant part, in the product part, what you are getting aldehyde, right? Suppose you substitute one of the hydrogen by methyl. So just you can see here there is CH3. So nothing is there in the sense what it is CH3. Okay. So this CH3 again upon treatment with mercury sulfate in acidic media, you will get ketone as a product. Okay. So overall in the preparation of aldehyde and ketones, whenever primary, secondary alcohols and their conditions you have to check. Okay, so just I'm revising it again and again. So whenever the primary alcohol is being given, go for aldehyde preparation. You are getting aldehyde as a product. Suppose you are taking secondary alcohol. So secondary alcohol, treat with PCC or PDC, what you will get? You will get ketone as a product. Okay, and now in case of hydrocarbons, just consider simple alkenes, just do ozonolysis, O3 treatment, you will get ketone and aldehyde. And apart from that, what you have, the alkyne upon treatment with HgSO4 in acidic media, you will get aldehyde, and the substituted alkyne you will get ketone. That's it. Nothing else is there in the overall preparation of aldehyde and ketones, right? I hope you are understanding. Yes, yes, Shrivani. Very good evening. Ram, hello. Yeah, I hope all of you are enjoying the preparation of aldehyde and ketones. Already have enjoyed, right? And is there any doubt, you can ask me in the chat box. I am always ready to help you. Okay, so if you don't have any doubt, we'll move further. Okay, coming to the next preparation is preparation of aldehyde. So just let us look at only preparation of aldehyde. Okay, so in case of preparation of aldehyde, the flow chart overall you can look at this. Okay, so why I have mentioned in this manner, why I have mentioned, because whenever you are studying any reaction, you have to make one flow chart in such a way that you can study by comparing each reaction. If you have the comparing thing in your mind, so then what you can do, you can say, I'm getting one named reaction in which I'm using this reagent, I'm getting the same product. So the product will be same, but the reagent what you are using and the name reaction whatever you are giving, that is completely different, right? That's why just let's start with the preparation of aldehyde. So coming to first is from acyl chloride. So from acyl chloride, how you can prepare aldehyde? So just consider you have benzoyl chloride. Okay, so just consider you have benzoyl chloride here. So this benzoyl chloride upon reducing, so H2, this is H2, and palladium in barium sulfate, you have palladium in barium sulfate, you will get benzaldehyde as a product. So what you have to do here overall, so just you have to do one thing. So just let us look at this chlorine. So this chlorine will go out, and the hydrogen, whatever you can see, H2, so it will go and bind to the electron deficient carbon, where you are reducing the benzoyl chloride to benzaldehyde. That's it, nothing else is there. So this reduction reaction in the presence of H2 in palladium over barium sulfate, we call it as a Rosenmund reduction reaction. Okay, so this is what the first named reaction you can check in the aldehyde preparation, right? What we have studied Rosenmund reduction reaction. Okay, so in case of Rosenmund reduction reaction, what is the reagent you are using? H2 over palladium in barium sulfate, right? So this is what first from acyl chloride preparation. We are done with acyl chloride preparation from acyl chloride. Now we have to move on from hydrocarbon. So from hydrocarbon, you can see easiest one. So just start with the toluene. This is toluene, alkyl benzene also we can say, where the methyl group is alkyl part. That's why I will call it as toluene. And toluene upon treatment with chromyl chloride in carbon disulfide, it will give me aldehyde, right? So this reaction where the chromyl chloride you are using, chromyl chloride you are using, so this reagent, whatever you are using, so this reaction overall we call it as a Itard reaction. Okay, so what we call it? We call it as Itard reaction. So just what happens here? Firstly, there will be toluene. Okay, so you will add the chromyl chloride, that is CrO2 and Cl2. So it will form firstly chromyl complex. Okay, so just it will form complex, and overall, so there will be two, right? And now what you will get? You will get aldehyde as your product, right? So this overall named reaction, what we call it as a Itard reaction. So this is what our second named reaction we have studied in aldehyde, right? Now coming to the next part, the most famous reaction is Gattermann-Koch reaction. So just you are starting with either benzene or substituted benzene, okay? And you are treating with carbon monoxide in HCl and anhydride AlCl3 in CuCl, you will get benzaldehyde as a product, right? So everywhere you can check for the named reaction where the reagents are changing but the product is one and same. The product is one and same. That's why I have shown you how to represent while writing, how to remember before the exam. You can just glance it, right? So that's why I have shown you. And apart from this, from nitrile also you can prepare aldehyde. So how you can prepare? So just take nitrile. So now I have taken cyclic cyanide or cyclic nitrile, I can say. Upon treatment with tin chloride in HCl and water, and just by heating you will get aldehyde. So firstly what happens here, overall this nitrile, whatever you can see, so just I will show you. So carbon C triple bond N, you can write it like this, right? So cyanide you will write with C triple bond N. Now you are treating with tin chloride in HCl, right? So in HCl you are writing. And now what happens upon treatment with tin chloride, firstly imine will be formed. So just what happened? Firstly imine will be formed here. Okay, so this imine further upon hydrolysis, what you will get? You will get aldehyde. That's it. Nothing else is there, right? So overall, how many reactions we studied? We studied four types of reactions, that is stiffened reaction, that is from nitriles, whatever the aldehyde you are preparing, that we call it as stiffened reaction. So four named reaction, one is Rosenmund reduction, and nextly Itard reaction, right? And nextly Gattermann-Koch reaction, and nextly stiffened reaction. So four named reactions from aldehyde chapter you have to remember, right? So just mark it down. And already I have shown how to represent in order to analyze it faster, right? So just go through this. And now coming to the next part is preparation of ketones. Okay, so preparation of ketones, as you can see overall. So from acyl chloride I can prepare, from nitriles I can prepare, from benzene or the substitute benzene it can give me aldehyde. Okay, coming to the first part from acyl chloride. So how you can prepare from acyl chloride? So you have acyl chloride here, right? So acyl chloride, how you can split? You can split where the carbonyl carbon will be your electron deficient, right? So this will be just, I will put here positive charge, okay? And now Cl will be negatively charged, right? So here the Grignard reagent, and upon treatment with CdCl2, you are going to get the alkyl cadmium. This is dialkyl cadmium. This dialkyl cadmium, where it will be added to carbonyl carbon. It will be added to carbonyl carbon, and simultaneously the chlorine will go out and you will get ketone as a product. So this is first reaction method, where preparation method, where you are getting ketone as a product from acyl chloride upon treatment with dialkyl cadmium, right? Now coming to the next reactions from nitrile. So from nitrile, again what you have, cyanide, right? So you can see overall, and you can have your Grignard reagent. How you can split? This is negatively charged, and magnesium is electropositive element, where you can show positive charge on it, right? So just show positive charge, right? Now you can see here the cyanide, whatever you can see here, this cyanide. So one of the pi bond will broken down here. So remaining two pi bonds. So two pi bonds are remaining. Now carbon will be electron deficient, right? So carbon will be electron deficient, nitrogen will be electron rich, right? So C6H5 will go and attack on the carbon, and MgBr is a positive part which will go and attack on the nitrogen, right? Next, what happens? Whatever, so just I will show you here, C triple bond N you are having. So just I am breaking this one bond. After breaking, what you have? You have your Grignard reagent. So just I will show here MgBr. Right. So this is positively charged and benzene is negatively charged. So this will attack on carbon, and the nitrogen will be carried by this positive part MgBr. So now you have your carbon which is attached to benzene, right? And now very adjacent to that, the carbon where it is attached to nitrogen, right? So this nitrogen is attached to MgBr, magnesium bromide. And now what happens overall? Just upon hydrolysis, you will get your ketone. Okay, so you will get your ketone overall here. So just you have to place oxygen in the place of nitrogen. So just break the bond and add oxygen there. That's it. So this is from nitrile. So we are done with from acyl chloride and from nitriles, and our next part is from benzene or substituted benzene. So from substituted benzene, if you consider any, like on benzene, you can place any methyl group, alkyl group, or any electron withdrawing groups like that. Okay. So right now you have the benzene upon treatment with acetyl chloride or acyl chloride in the presence of anhydrous AlCl3, where it is Lewis acid, right? So next what happens? The acyl group, where the carbon and chlorine bond has to be broken down, and this CO plus will go and attack on the benzene, where we can say substitution reaction. So overall it is what you are getting ketone, right? So from substituted benzene also you can get, or else just simply by considering benzene also you can get the ketones. That's it. So overall, how many? Three reactions we studied from acyl chloride and from nitriles, and lastly from benzene, just Friedel-Crafts acylation we have done. So this is our next Friedel-Crafts acylation reaction, the name reaction, whatever we have seen in ketone part, right? And now coming to next part, okay? So that is regarding carboxylic acid. Okay, so in case of carboxylic acid, there are so many methods in order to get carboxylic acid. Just let us consider the important preparation methods of carboxylic acid. Okay, so the first thing is using Grignard reagent. Already I have shown you how you can show the positive and negative part from the Grignard reagent, right? So now you have CH3MgX here. So just I will write it here, CH3MgX, right? So with what you have to treat? First you have to treat with CO2. So just I will treat with CO2. So I can show it like this. So now this carbon is what? It is electron deficient. So I will show the partial positive charge there. And we know that from Grignard reagent, CH3 will be negatively charged and MgX will be positively charged, right? So now I will directly attack on this carbon, right? I will shift the electron towards the oxygen because the carbon is overall attacking, right? So the CH3 minus is attacking on the electron deficient carbon. And later what happens? You will get the CH3 and CO. Another side you have your oxygen, right? And which is attached to MgX. Okay, so this is what you have. Next, this bond will break broken down and it will go out and it will directly give me acetic acid as a product. Okay, so this is from Grignard reagent. Now coming to the next part is from alkyl benzene. So from alkyl benzene, how you can form? So just consider you have toluene. Okay, so just consider you have your toluene. I will show here itself. So this is what your toluene. Okay, so you're treating with KMnO4 in KOH and you're further following the acidic hydrolysis. So first what happens? So this toluene which is carrying CH3 and where you're treating with KMnO4. Okay, so first what you will get? You will get potassium salts of benzoate. So just I will show it like this. COOK you have got. Next what you have to do? You have to do acidic hydrolysis. So just do acidic hydrolysis. You will get simple benzoic acid as a product. Okay, so this is what we are preparing from alkyl benzene carboxylic acid, that is benzoic acid you have prepared from toluene now. Okay, I hope students you are understanding. If you are understanding, please comment as yes in the chat box. Yes, and coming to the next part is from nitriles. Okay, so from nitriles, how you can prepare carboxylic acid? Same thing. Again, what you have? You have your CH3, CN now, C triple bond N. You have, and you have to treat with water. So water, how you can split? You can split like H plus and OH minus, right? So now what you have, just break one pi bond from C triple bond N. Now carbon will be deficient, so that will be carrying OH minus and nitrogen will grab this proton and you will get CH3 C and where you can show OH double bond NH you have, right? So now this CH3 whatever you can see here overall. Okay, so now this OH where you have the oxygen is carrying proton, that has to be deprotonated. So once you deprotonate it, the nitrogen whatever it is carrying lone pair, it will grab this and simultaneously it will form the bond. Okay, and you will get firstly the amide here. So first what you will get? You will get amide as a product. Okay, so CH3CONH2 you will get. And next what happens? Overall, nextly, again you have to heat it and just do hydrolysis. You will get your simple carboxylic acid. So just I will write it as CH3COOH. Okay, so this is what overall method we can follow from nitriles to carboxylic acid formation in the presence of just by doing hydrolysis. Okay, so these are what the method we have studied with respect to nitriles. Now coming to the last part is from acyl chloride. So from acyl chlorides also or acyl halides also we can get carboxylic acid. So just you have CH3COCl here. So CH3COCl you can break the bond like this. So electron deficient carbonyl center you have, right? So this electron deficient carbonyl center will be attacked by the nucleophile OH minus and it will attack and directly you will get acetic acid. Apart from acyl halide, you can prepare from anhydride also. So this whatever you can see here, this is anhydride, right? So this anhydride, just upon hydrolysis, you will get benzoic acid as a product. Okay, so these are what the 4 preparation methods for preparation of carboxylic acids. Okay, apart from this, is there any method we can prepare carboxylic acid? Yes, you can prepare. Just if you consider any ester, Okay, if you consider any ester, if I have C6H5, COO, C2H5, and I will just do acidic hydrolysis H3O plus, and you will get benzoic acid along with alcohol, that is C2H5OH. Okay, so just there will be two hydrogens over this, and here it will be carrying one methyl group. That's it. So apart from these four methods, we can prepare the carboxylic acid from esters also just by doing acidic hydrolysis. Okay, so this is what the four methods we have studied. Overall, we completed the preparation method of aldehydes, ketones, and carboxylic acid. Okay, further we have to move on to reactivity part. So before that, I want to check how much you have revised your syllabus, that too from aldehyde, ketones, and carboxylic acid, and how much you understood whatever I have explained now. So just let us solve few problems on this chapter. So just consider. Okay, so the problem is like this. Okay. Okay, so the first reaction, first question is the reaction by which the benzaldehyde cannot be prepared. So they are asking you the question, the options, whatever they have given the reactant part. So now you have to tell me that which reaction in the given option, which reaction will not give me benzaldehyde. It should give, no, it should not give the benzaldehyde. So they are asking which cannot be prepared. So just answer me faster, students. So I will be waiting. So if you know the answer, please answer in the chat box. So just whatever I have explained in the preparation part, only the answer is there. So Sneha's answer it is A, and Stunner something. There he is answering C. Yes. Okay. Just let us look at the solution. Okay. So in case of solution part, what they are asking? They are asking benzaldehyde, right? So already for benzaldehyde, we know the preparation methods, and there are named reaction, Gutterman-Koch reaction, Itard reaction, Rosenman reduction, right? And Stephen reaction we studied overall. And over here, they have given options A, B, C, D. You can see the option B has to be correct, because nowhere in the preparation part we have discussed with a zinc amalgam in HCl, right? So nowhere in the reaction part we have not studied the zinc amalgam in concentrated HCl, right? So just let us look at this. So first option A, whatever you can see, benzene with carbonyl, that is CO, and HCl in presence of anhydride AlCl3 you have. This is what? This is Gutterman-Koch. This is Gutterman-Koch reaction, right? Now the option C, whatever you can see, it is toluene they have given, and they're treating with CrO2 Cl2 in CS2 followed by H3O plus. So in the sense what? It is Itard reaction. Yes, it is Itard reaction. And then the option D, you can see the benzoyl chloride you have in the presence of H2 in presence of palladium barium sulfate. So this is Rosenmund reduction reaction, right? So whatever the options they have given, here we have Gutterman-Koch, Itard, and Rosenmund reduction, but we are not familiar with the benzoic acid treatment with zinc amalgam and concentrated HCl, right? So now the option B is correct. Okay, so now coming to the next example, next question. Okay, so the next question is like this: the oxidation of toluene to benzaldehyde by chromyl chloride is called. It is very easy question, right? So these all questions, whatever I'm discussing, these are already asked previously in NEET examination. So just answer me what options you can choose for this given question. Yes, Smita is answering A, and Sneha is answering A. Stunner, where he is answering A. Okay, okay, just let's look at this. So we are preparing benzaldehyde by chromyl chloride. So chromyl chloride reagent is being given, then definitely it has to be Itard reaction, right? So the option A is correct. And the Riemer-Tiemann reaction we have not discussed, and the Riemer-Tiemann reactions will not give the benzaldehyde, and not even Woods reaction and Canizaros reaction, right? So now in the given options, the option A is correct. Okay, now we'll further move on with the preparation part. Okay, and now coming to chemical reactions of aldehydes and ketones. Okay, so now just let us look at overall the chemical reactivity part, how exactly the aldehydes, ketones and carboxylic acid can be treated with simultaneous reagent, what product you are getting. Okay, so there are four reactions. One is nucleophilic addition and reduction reaction, oxidation reaction and reactions due to alpha hydrogen. So each one of the reaction category we are going to revise now faster and effectively, right? So all of you are ready, I guess, right? So just let us start this. So firstly, you can see the first is nucleophilic addition. So before starting the actual part of nucleophilic addition reaction with respect to aldehyde and ketone, you have to know the carbonyl group reactivity part in aldehyde and ketone. Okay, better you know the aldehyde part is carrying one hydrogen and one alkyl group. So just I will consider R, and just let me explain first this and I will correlate with the ketone. So coming to the aldehyde carbonyl group, whatever you can see here, this carbonyl carbon is more electron deficient compared to ketonyl carbon. Okay, so why? Because here overall it is carrying only one side alkyl part and another side it is carrying hydrogen, right? In case of ketone, what happens? In case of ketones, you have carbonyl group, one side alkyl part, another side again alkyl part, right? So two side the carbonyl group is attached to two carbon atoms or the two substituents, whatever you can say. So this carbonyl group, where this carbonyl group, whatever you can see here, its electron density will be more. What we want, in order to carry out the nucleophilic addition reaction, the carbonyl carbon has to be electron deficient, right? Then only the electron rich source will go and attack on the electron deficient part, right? That's why the aldehyde's reactivity will be always more than that of the ketone functional group. Okay, so the reactivity part of carbonyl group with respect to nucleophilic addition reaction will be more than that of ketone, right? So now you have to keep this in your mind, and then just let us start with the nucleophilic addition reaction. So first example is addition of hydrogen cyanide. So what you have aldehyde here and you have your ketone also. Okay, so now what you have to do, you have to treat with HCN hydrogen cyanide. So you can split like H plus and Cn minus, right? So we know that electron deficient carbon is carbonyl carbon, right? So now this cyanide will go and attack on the carbonyl carbon, and you will get here firstly like this. So Cn will be there, and the carbon where it is carrying oxygen and negative charge, another side it has CH3, and another side it has methyl group, right? So upon attacking Cn minus to the carbonyl group, you have got this. And now what you have to do, you have to protonate this oxygen. Suppose you protonate this oxygen, you will get directly cyanohydrin. So you will get cyanohydrin here. Overall, whenever you are considering any aldehyde or ketone, if you consider, okay, aldehyde or ketone, so aldehyde ketone, whenever you consider, overall, whenever you treat with HCN in the presence of base, so OH minus is a base, and you will get cyanohydrins as a product. Okay, so this is one nucleophilic addition reaction. Now coming to the next nucleophilic addition reaction is addition of hydrogen sulfide. So addition of sodium hydrogen sulfide. So you can see it is any carbonyl group, either aldehyde or ketone. Okay, so just I have mentioned generally. Now this sodium hydrogen sulfide, what it will do, it can split like it can split like Na plus and HSO3 minus. So this will be positive part, and HSO3 minus will be negative part. Negative part will go and attack on the electron deficient carbon, and Na plus will go and attack on the negatively charged oxygen. Okay, so the electron deficient carbon will be attacked by HSO3 minus, and Na plus will go and attack on the oxygen. So what you will get here, this is your central carbon, this central carbon which is attached to SO3H one side, and again oxygen has binded to sodium, right? Now you have to transfer the proton. You have to transfer the proton where you can see this sodium has come here and hydrogen has here. So overall, just by protonating, just by transferring the proton here, so this proton and sodium, you will get the bisulfite adduct, that is addition product. And this reaction is reversible. Just by maintaining some reaction conditions, you can get back your carbonyl group as it is. Okay, so this is another example for addition of sodium hydrogen sulfide. And now coming to next reaction part is addition of alcohols. So addition of alcohols where you can overall see, okay, so this is aldehyde and ketone you have, and you have to treat with ketone, sorry, alcohol. So first you treat with alcohol in the presence of HCl gas. First what happens here, first there will be carbonyl group, one side it has H and another side it has CH3. So now what you have alcohol, ethanol. So it can be splitted as C2H5O minus and H plus, right? So this C2H5O minus will go and bind to carbonyl carbon, which is electron deficient, right? And you will get CH3CO minus and H, and here you have your newly bonded product, right? So how you can get here overall, so this is the method where the oxygen and it is carrying C2H5. So like that, another mole of alcohol you have to consider, that is C2H5OH you have. So just you have to attack the same method and you will get directly acetal as a product. Suppose you're starting with the aldehyde, you will get acetal as a product. Suppose you are considering ketone, and where you are treating with ethylene glycol, this is ethylene glycol upon HCl gas, you will get this ethylene glycol ketone. If you are starting from aldehyde and you are treating with alcohol in the presence of HCl gas, you will get acetal as a product. And if you are starting from the ketone and you are treating with ethylene glycol in the presence of HCl gas, you will get as what, ketone as a product. So just I will mention it as a ketone here. Okay, so this is what, another nucleophilic addition reaction. Okay, yes students. And then next method, okay, so next addition method, nucleophilic addition method, addition of ammonia. So addition of ammonia, as you can see, same carbonyl group you have to consider, either it is aldehyde or ketone, treat with ammonia derivative. So now NH2Z, whatever the Z you can see, it is nothing but either alkyl, aryl, OH or NH2. Suppose you consider Z where it is NH2, it will be like hydrazine, right? So NH2 is hydrazine. Suppose you consider NH2OH, then it will be hydroxylamine, right? Like that, you have to treat with NH2Z where Z is alkyl, aryl, OH or NH2. So these are the substituent part you have. Just upon treatment here, what happens? The nitrogen which is electron rich and the carbonyl carbon is electron deficient, right? So this will go and bind to the carbon and the oxygen where it is shifting the electron towards oxygen, and the oxygen will be protonated from one of the proton of the nitrogen. Okay, and now you can see this in the bracket, right? The carbon which is attached to OH and NHZ. So now what you have to do, overall you have to remove 1 mole of water molecule. So now this hydrogen, okay, so this OH and this H, okay, so this OH and H will go out as a water molecule and you will form C double bond N Z as a product. Okay, so this is another method or the another example for the nucleophilic addition reaction. And now coming to the next part. So the next part you can see reduction reaction, and these are the two famous reduction reactions. Okay, so two famous reduction reactions you can see, one is Clemenson's reduction and another one is Wolff-Kishner reduction. Okay, so in case of Clemmenson reduction and Wolff-Kishner reduction, what you are going to do, just you are going to reduce this carbonyl group to CH2. So you can see in both the reaction, the CO group is reduced to CH2. So just remove the oxygen and add hydrogen. That's it. What is reduction? Just you are either removing oxygen and adding hydrogen. What is oxidation? Either you are adding oxygen and you are removing hydrogen. So now what we are doing here, we are doing reduction. So reduction in the sense where you have to add hydrogen, remove oxygen. Okay, so right now in the given reaction where the oxygen is removed and hydrogen you are adding in the presence of reducing agent, that is zinc amalgam in HCl, right? So zinc amalgam in HCl, and you are getting the reduced product, and this reaction overall we call it as a Clemmensen reduction. So in case of Clemmensen reduction, the reducing agent must be zinc amalgam in HCl. Okay, and now coming to the next reaction is Wolff-Kishner reduction. Everything is one and same. You are reducing the same carbonyl carbon. So this carbonyl carbon where you are removing the oxygen and you are adding the hydrogen. So you are adding the hydrogen, but the reagent is hydrazine you have in KOH, ethylene glycol. Just you have to heat and you will get your reduced product. That's it. So in Clemmensen reduction, zinc amalgam in HCl you are using, but in case of Wolff-Kishner reduction, what you are using the same where the carbonyl group is reduced to CH2 in the presence of hydrazine in KOH and ethylene glycol, right? So this is what the reduction reaction. Okay, now coming to the next part. Okay, next part is oxidation. So the oxidation test, whatever we can do for aldehydes and ketones, it is mainly like we can distinguish mainly aldehydes separately and ketones separately. So aldehydes where we can prefer two tests, one is Fehling test and another one is Tolan test. So coming to the first test, that is Fehling's test, what you are going to do here. So in case of Fehling's, there will be two solutions. One is Fehling's A, another one is Fehling's B. Okay, so this Fehling's A is copper sulfate. This is copper sulfate solution, and Fehling's B solution is what? Fehling's B solution is Rochelle salt. This is Rochelle salt, and both has to be mixed, and that will be treated with aldehyde, and it will give me carboxylate as a product, and it indicates the presence of aldehyde in the given sample. So this mainly we do in the laboratory method, right? So this is what we can distinguish aldehyde and ketone from each other. So for ketone we go for methyl ketone test, but for aldehyde we can prefer Fehling test and Tolan's test. Okay, so coming to the Fehling test again. So copper sulfate, what it will do? So this copper sulfate, first it will be, treated with NaOH base. Okay, so just consider 2 moles, and what you will get here, you will get copper hydroxide. Along with that, sodium sulfate you will get, that is Na2SO4. So this copper hydroxide, it will not keep itself quiet. It will further react with the Fehling solutions B, that is Rochelle salt, right? So this will be like CHCOO Na, and again here CHCOO K you have, right? Another side you have OH. Okay, and here what happens, simply I will show you here. So this copper which is carrying two hydroxides, so it will overall go and it will form the complex like this. So it will be like oxygen which is further attached to CH here, and again oxygen. Okay, and here it is attached to one side COO Na, and another side COO K. Okay, so this is what overall you are getting the Fehling's blue solution. So first you have to mix your Fehling's A and Fehling's B solution, and you will get your blue color solution. So that blue color solution where it is carrying copper 2 plus, okay, so overall it will be reacting and it will give me carboxylate ion as a product, and it will indicate the presence of aldehyde in the sample. That's it. So this is what the oxidation reaction we can say with respect to Fehling's test. And now coming to the next part is Tolan's test. So in case of Tolan's test, what you have to do? You have your benzaldehyde. So this benzaldehyde will be treated with diamine silver 1 hydroxide. Upon adding water, you will get your benzoic acid. Along with that, Ag and NH3 gas is evolved, and water is also eliminated. And you can see overall the test tube colors. So the positive test indicates the formation of red ppt here, right? So red or red brown ppt, you can see this is what the failing solution test. And the tolerance test, whatever you can see here, it is forming ammonical silver mirror test, we can see, right? So it is forming what, where the silver is present in the test tube, that's why it is giving me silver color. That's what the oxidation of aldehydes by failing test and tolerance test. Okay, and students, do you have any doubt? I hope you are understanding. Okay, now coming to the next test is haloform test. Okay, so the haloform test or iodoform test, better you know, right? So here what happens, any ketone or any carbonyl group which is having methyl ketone part, here specifically upon treatment with sodium hypohalite, so here NaOCl we have used, so X can be anything, Cl, Br or I. Okay, so now NaOCl treatment, it will give me carboxylic acid salts, right? So the sodium salts of substituted carboxylic acid you are getting, along with that CHCl3 is formed, right? So this is what the haloform test with respect to aldehyde and ketone. So specifically we do this for ketone distinguish test from aldehyde, and for aldehydes what we have preferred, we have preferred Fehling test and tolerance test, right? So these are what the oxidation method of aldehyde ketones, right? And now coming to the next preparation method is reactions of alpha hydrogen. So reactions of alpha hydrogen, that is due to alpha hydrogen, that is most important case in case of NEET chemistry, because most of the reactions or the example, whatever the questions are being asked previously, most of them are having based on this alpha hydrogen. So what exactly alpha hydrogen? First you have to know. So alpha hydrogen is whenever you have carbonyl group which is attached to any carbon this side or else this side, I can say. So this carbonyl group which is attached to the carbon, and this we call it as the alpha carbon. Okay, so the carbonyl group which is attached to next carbon, and next carbon, this carbon we call it as a alpha carbon, and the carbon which is carrying hydrogen we call it as a alpha hydrogen, right? So this alpha hydrogen is most reactive because whenever you cleave this hydrogen upon cleaving, what you will get, so just I will show you here. Okay, so just I will show you here. So you have your carbonyl group, and which is carrying carbon which is alpha carbon, and there is hydrogen. So this will be grabbed by any base, so just grab it, and now what it will form, so just I will show you here the carbonyl group which is carrying carbon and negative charge, right? So negative charge, this can be mainly stabilized by resonance, right? So this charge can be stabilized mainly by resonance. That's why its conjugate base, whatever you have formed, it can be stabilized by resonance. That's why the alpha hydrogen will be more reactive with respect to the aldol condensation or cross aldol condensation, whatever we are going to study now. Okay, so one thing you know about alpha hydrogen now, and now we have to start with the aldol condensation first. So just let me know about the aldol condensation first, then we'll move on with respect to crossed aldol condensation. So aldol condensation. Okay, so aldol condensation, whatever you can see here. So aldol condensation overall, it is carried for the aldehydes or the ketones which are carrying alpha hydrogens adjacent to carbonyl group. So now even in the given reactant part where the acetaldehyde you have CH3, COH, right? So this carbon will be alpha carbon to this carbonyl group, right? If it is alpha carbon, it is carrying 3 protons, so just kick out 1 proton in the presence of base. So how you can remove? So now I will show you how you can remove overall. Okay, so now aldehyde you have H, I will write here, and it is carrying 3 protons. Okay, and now I will treat with any base. Suppose I take sodium hydroxide, and just I will show it like this, which is electron rich. I am indicating, and now I will just grab this proton by using base, and then what happens, it will form carbanion type, right? So now this carbon, where you can see carbonyl carbon and this carbon, upon losing one proton where it is carrying negative charge and another side it is carrying the hydrogen as it is. Now I can shift this bond, this electron shift here, and again this bond towards the oxygen. So what you can see? So you can see enolate formation, right? So what you can see enolate formation, and overall you can say CH2 and here H you have. So this enolate, what it will do further, it will be treated with another mole of acetaldehyde. Okay, so just I will show you overall. Okay, so now what you are having, enolate, right? So C double bond C, CH2 you are having, and another side you have hydrogen. So now another mole of acetaldehyde I will consider. So here this carbon is electron deficient, right? Now this carbon will be electron rich because upon shifting this here, so overall what you will get here, so this carbon where it will be like this H and newly formed bond, so this CH2 will be binding to the carbon. Upon attacking, this oxygen will be carrying negative charge, another side it has H and another side it has CH3, right? So now what you have to do further shift this bond. So before that what I can do, I can just protonate this. Okay, so this oxygen has to be protonated, so just I will write it as H here. So if I write it as H, now to this carbonyl carbon you have alpha carbon. So alpha carbon which is carrying proton, it is more reactive and easy to remove, right? So now I will remove one of the proton. So just I will show here. So one of the proton I will remove, and only just I will write like this so that you can understand it very well. Okay, so now one of the proton I have written and OH you have. So just remove H2O. If you remove H2O, you will get alpha beta unsaturated aldehyde. Carbonyl compounds, we can say alpha beta unsaturated carbonyl compounds you will get just upon aldol condensation. So aldol condensation, so first thing the aldehyde must have alpha hydrogen, right? And then it can be catalyzed either using base also, acid also. In case of acid, what happens, you just protonate the oxygen first and then you will further carry out the next treatment of another mole of acetaldehyde and you will get your alpha beta unsaturated carbonyl compound. Okay, and now coming to cross aldol condensation. Okay, so in case of cross aldol condensation, what happens? So if we have the same aldehyde or the same ketone molecules, then we can follow for the aldol condensation. Suppose we have different aldehyde or different ketones, then what we can do? We can go for cross aldol condensation. So you can see here two different aldehyde, right? So this is ethanol, this is propanol, right? Both are different aldehyde. If I am following the same condensation method, whatever we have used here, upon treatment with NaOH in water, you will get 4 different products here. Okay, you will get 4 different products whenever you consider two different aldehydes. Suppose you consider ketone also, so either two different aldehyde or two ketones, you will get 4 different products upon cross aldol condensation, where you are maintaining the same reaction condition, you are treating in the presence of base and you are doing hydrolysis at last, and you will get your what, alpha beta unsaturated compound. Okay, and I hope you are understanding the reactions, students. If you are understanding, please ping me, right? Yeah, okay, so now we'll move on further. That is, if there is no alpha hydrogen. So right now we have the condition for aldol condensation where we have the alpha hydrogen. Suppose any aldehyde which is not carrying alpha hydrogen, then what it will do? It can undergo Cannizzerose reaction. So it can undergo Cannizzerose reaction. Okay, it can undergo Cannizzerose reaction. Suppose you have formaldehyde. So just simple example I will give. Suppose you have formaldehyde and you can see adjacent to this carbonyl group, there is no any carbon. Simply you have two hydrogens, right? So what is alpha hydrogen? the carbonyl carbon adjacent to which the carbon which is carrying 3 hydrogens or 4 hydrogens, so whatever the 3 hydrogens adjacent to each, whatever you can see, that we call it as the alpha hydrogen, right? So now you cannot see any alpha hydrogen or alpha carbon. That's why, so this type of reactants, whenever you consider 2 moles of formaldehyde, it will undergo Cannizzarose reaction and it will give the product here. So now what you have to do here overall, so just treat in the presence of base and you will get your Cannizzarose product. Okay, and overall, first thing, whenever you have alpha hydrogen and you will get your aldol product. Okay, and whenever any reactant part like benzaldehyde or formaldehyde, if they are not containing any alpha hydrogen, it will undergo Cannizzarose reaction. Okay, and now coming to the next part is with respect to chemical reactivity of carboxylic acid. So just let us look at the carboxylic acid part here. Okay, so till now we completed aldehyde ketones. Okay, and now coming to the carboxylic acid, so three categories we can have. One is whenever you can see carboxylic acid, where you have either oxygen hydrogen bond breaking or else carbon oxygen bond breaking. So just I am mentioning in a bracket. Okay, and now another type where overall the carboxylic acid might be involved in order to change into another functional group. Okay, so this is what the three categories we can say with respect to the chemical reactivity of carboxylic acid. Okay, and now coming to overall here. Okay, so first is reaction with metal. So what happens if you treat with metal? Suppose you have benzoic acid and just treat with sodium hydroxide, or you can just simple take sodium metal in 2 moles and you will get sodium salts of benzoic acid. Along with that, the water has come out. Okay, so this is what the cleavage of oxygen hydrogen bond. So you can see clearly. So this is what the oxygen hydrogen you have. So C6H5 COO minus, you can split. So C6H5 COO minus H plus you have, and NaOH where Na plus OH minus you can split. So this OH will combine with water and it will go as water molecule, and the sodium plus or the Na plus you have, it will combine with oxygen and it will give me sodium salts of benzoate, right? So this is what the salt formation you can see with respect to oxygen hydrogen bond cleavage. Now coming to the next part is reaction involving cleavage of carbon oxygen hydrogen bond. So here, so just let us look at this reactant part. So you have 2 moles of ethanoic acid. Okay, so 2 moles of ethanoic acid you have. Just upon heating in the presence of acid, you are going to form anhydride. So now what you have to do, just remove the water molecule here. This water molecule you can cleave and you can get anhydride as a product. So whenever you have the carbon oxygen cleavage by considering the carboxylic acid, you will get anhydride as a product. Okay, so these are what all over the carbon oxygen hydrogen bond breaking reaction part. Now coming to the next is reaction with PCl3 and PCl3. Here also you are going to cleave the carbon oxygen bond. Okay, and you are going to get the acyl chlorides or ethanol chloride also we can say. So overall here first you consider the ethanoic acid. Upon treatment with PCl3 you can get ethanol chloride, that is CH3COCl, along with the side product H3PO3. And now the ethanoic acid will be treated with PCl5 and you are getting the same product, which is ethanol chloride, and POCl3 with HCl is released out. Apart from that, every time whenever you are treating with thionyl chloride, that is SOCl2, this ethanoic acid will be giving me the completely pure ethanol chloride by evolving SO2 and HCl as a gas. Okay, so the SO2 and HCl can be released out as a gas molecule, and whatever the product you are getting, it is pure product. Okay, so this preparation method or the whatever the reactivity part you can say, this is mainly preferred rather than treating with PCl3 and PCl5. Okay, and now coming to the next part of reactivity is reaction with ammonia. So reaction with ammonia, simply it will give me amides as a product here whenever you are treating the carboxylic acid with ammonia. So now you have phthalic acid. This is phthalic acid we call, right? Because the benzene which is carrying 2 carboxylic acid groups and treat with ammonia, you will get the ammonium phthalate as a product. So ammonium phthalate how? So whatever you can see COOH you have, so 6H5COO minus H plus, right? So like that, just split and you can add NH3, right? It will bind to the carboxylate group, right? So nitrogen will be bound to the 4 bonds. So 4 atoms it has bonded, so it is carrying positive charge, and oxygen has bound to nitrogen and overall negative. So it will be like looking salt form, right? So now upon heating, just you are going to remove 2 water molecules and you will be getting phthalimide as a product. So this phthalimide, upon strong heating, you will get phthalimide as a product. So this is what you are treating the benzoic acid with ammonia. So whenever you treat the benzoic acid or the carboxylic acid with ammonia, you will get amide as a product. And this example is mainly based on phthalic acid treatment with ammonia, and you will get phthalimide as a product. Okay, so overall, how many? There are so many reactions for the carboxylic acid, right? So now coming to the next reaction part, that is reactions involving carboxylic group. Okay, so apart from cleaving of the carbon oxygen bond or oxygen hydrogen bond, where exactly either we can replace the carbonyl group, right? Either we can replace the carbonyl adjacent group, or else we can add any other thing. So like that we can carry out like decarboxylation, and another one is reduction. So coming to the decarboxylation, the sodium acetate will be treated with sodium hydroxide. Just upon heating with, in the presence of calcium oxide, you will get methane, along with that sodium carbonate as a byproduct. Okay, so decarboxylation, simply the carboxylic acid which is carrying COOH here, right? So this has to be eliminated. So just evolve it out as a gas molecule and you will get simply the hydrocarbons as a product. Now coming to the reduction part, simple, the reduction of carboxylic acid in the presence of lithium aluminum hydride by following acidic hydrolysis, it will give me propanol as a product. Or else what we have studied previously, the esters were upon acidic hydrolysis, it was giving me a carboxylic acid and alcohol, right? And now what you are doing, you are taking the same carboxylic acid and you are treating with what? Reducing agent, and you are getting alcohol as a product. So like that, there are so many reactions with respect to carboxylic acid. And one more reaction you can mention, that HVZ reaction. I hope you know regarding HVZ reaction, students, right? So in case of HVZ reaction, what happens? So unlike the carbonyl carbon which is carrying alpha carbon in case of aldehyde ketones, how exactly it is undergoing aldol condensation, and similarly in case of carboxylic acid also it is undergoing HVZ reaction. So HVZ reaction is just nothing but I'm going to show you exactly. So the carboxylic acid you have, and another side it has OH, and this side R, and in the presence of, you have to treat X2. So here X is nothing but chlorine and bromine, okay, and X2 in the presence of red phosphorus and Br2. So Br2 is nothing but the X2 here I am using. So now what happens, this carboxylic acid, whatever this R I have mentioned, so just let me consider it as a methyl group. So methyl group, whatever it is carrying proton, it is alpha proton, right? So alpha proton is most acidic and it will be released out. So once it releases out and the bromine go, it will go and attack on the carbon. So it will be attacking like what you will get here, hydrogen and Br, okay, and here you will be having your COOH, so it might be attached to something else. So like that, the HVZ reaction where any carboxylic acid functional groups you consider. So overall, if it's carrying the alpha carbon, so the alpha carbon which is carrying proton has to be replaced, or just by addition of halogen to the hydrogen replacement, you will get the alpha halogenated product. So just we call it as a halogenation reaction also. So HVZ reaction is halogenation reaction where you are getting alpha halocarboxylic acid. Okay, so this is what overall methods with respect to carboxylic acids, aldehydes and ketones. So overall we started from preparation method and the reactivity part, and I have shown you how exactly you have to represent the reactions in the flow chart. Go through that method, okay, so that you can easily revise one day before your exam. Okay, so with this I am about to end the preparation and chemical reactivity part. Now lastly we'll solve two problems. Okay, students, are you ready to solve the problems? Say yes. Okay, so coming to the first problem, you can see here with respect to reactivity part, the reaction between benzaldehyde and acetophenone in the presence of dilute NaOH is known as. So they have given the question like this. They have given the two reactant part, one is benzaldehyde and another one is acetophenone. So benzaldehyde and acetophenone in the presence of dilute NaOH is known as what type of reaction it is? Either option A, aldol condensation, option B, Cannizzaro reaction, and option C where cross Cannizzaro reaction, and option D cross aldol condensation. So I have shown with respect to the example. So just let me know what options you can choose for this question. Yes, students, hurry, please answer me. Yes, Smita is answering it as C. Anybody who else want to answer? Okay, yes, let's see. So what reactant part they have given? They have given benzaldehyde and acetophenone. So benzaldehyde will be, I will consider PH CHO, right? Along with that, you are treating with acetophenone. So just I will consider CO and one side CH3, right? And another side it is PH, right? So this is acetophenone and this is benzaldehyde. We can observe one thing in the given reactant part, the benzaldehyde is not carrying any alpha hydrogen, right? If it is not carrying any alpha hydrogen, then it can undergo Cannizzaro reaction, right? But the another reactant is carrying alpha hydrogen. So you can see here, this is the alpha carbon which is carrying 3 protons, and overall we can say that it can undergo aldol condensation in such a way that, so this carbon which is carrying 3 protons, first it will be acting as what? The first reactant part. So just what happens here, the CO, PH you have. So first in the presence of base, one of the proton will be grabbed and it will form enolate. So just I will form here, right? So once it forms enolate, right? So once it forms PH, CO minus and C double bond CH2 you have. And next what you have? Benzaldehyde. So now you have to attack this carbonyl carbon towards where this is electron deficient, right? So now this electron rich, so what you will get overall, you will get the product like this. So this will be PH, and very adjacent to that you have the carbon which is carrying oxygen, and now what happens, it will give back its electron back, right? So now this CH which is attached to newly formed this benzaldehyde, so I will show CH2C, and where these electrons are shifting towards oxygen which is carrying negative charge, and apart from that it is carrying one side hydrogen, another side phenyl group. So I will show phenyl group, right? And overall what you can see here, and now so this oxygen whatever it is carrying negative charge, it can be protonated. So just if you protonate and one of the hydrogen from this carbon, okay, so just I will show here one of the hydrogen from this carbon, so one hydrogen here, one hydrogen here, and this after protonation where it will be OH, and it will go out as a water molecule. So just remove water molecule, what you will get here overall, so just I will write it. Okay, so just I will write it here. So you can form the alpha beta unsaturated product. So you have your pH part as it is. Adjacent to that the carbon you can see, right, which is carbonyl group. And now this carbon is carrying CH, then double bond, then again CH, and which is carrying pH, right? So this is what the product you will get upon treatment with what? Benzaldehyde and acetophenone in the presence of dilute NaOH. Okay, so the option, what? Option D has to be done here. That is cross aldol condensation reaction. And now coming to the next reaction, next question. So last question, students. So answer me. So the question is like this. which one is most reactive towards nucleophilic addition reaction? So just choose the options and let me know what options you can give me the answer. Okay, I hope before starting the nucleophilic addition reaction, I have explained you why, what is the difference and the most chemical reactivity difference between the aldehyde carbonyl carbon and the ketone carbon, right? So here the nucleophilic addition reaction is mainly most reactive with respect to aldehydes. So in the given options, in the option A we have aldehyde, and in the second option we have ketone, in third option we have aldehyde, right? So now in the option D, we have electron withdrawing group at para position, and we know that it will make the electron deficient carbon, that is carbonyl carbon, more electron deficient by withdrawing the electron density towards it, right? That's why the option D has to be correct here. Okay, so I hope I have covered all the preparation and chemical reactivity part of aldehydes and ketones. And if you have any doubt still, you can ping me in the chat box. I'm ready to answer. And finally, thank you students for your patience, and still you have stayed tuned with me. And the next topic I will come up with a new chemistry topic where which is more important for your NEET syllabus. And like that, as I have told in the beginning, we have already displayed the feedback form in the description box. Along with that, you have one more thing where you can get the freebie of important topics of NEET chemistry syllabus. Okay, so the important topics, what and all you have to study, so that information you will get once you fill the feedback form. So don't forget to fill the feedback form and stay tuned with us. And still we have few more days to nail the NEET revision, right? So just let us nail it together. Until that, thank you, bye bye.